Disclosure. This educational content has been developed using artificial intelligence.
How a submarine dives and surfaces. The science of deep-sea stealth, it's one of the most powerful and mysterious machines ever created. A vessel that can descend into a world of perpetual darkness, withstand pressures that would crush steel like a soda can, and then return to the surface at will. For centuries, the dream of exploring the deep sea was just that, a dream. So how did we conquer this incredible challenge? How does a giant, heavy ship, made of thousands of tons of steel, not only sink but also control its depth with such precision, and then effortlessly rise back to the air and sunlight? Welcome. In the next 7 minutes, we're going to unravel the brilliant, yet surprisingly simple, physics that allows a submarine to dive in the surface. Forget complex engineering jargon. We're going to follow the journey of a submarine using one key principle that each and every one of us has experienced. Let's dive in. To understand a submarine, you first need to understand one fundamental concept: buoyancy. It's the upward force that water exerts on any object placed in it. Think of it this way: when you try to push an empty plastic bottle underwater, you can feel the water pushing back, trying to make it float. That's buoyancy. Now, if you take that same bottle and fill it with water, it'll sink. Why? It all comes down to density. An object will float if it is less dense than the water it displaces. It will sink if it is more dense. And it will hover underwater, neither sinking nor rising, what we call neutral buoyancy, if its density is exactly equal to the water around it. This is the submarine's secret. It's not about having engines that push it down. It's about masterfully manipulating its own density to become heavier than water to sink and lighter than water to rise. And it does this with two brilliant systems: ballast tanks and diving planes. Let's start with the dive. Imagine our submarine is cruising on the surface. Right now, it's acting like a ship. Its large, hollow compartments, called main ballast tanks, are full of air. This makes the overall submarine less dense than water, so it floats. To sink, the submarine needs to become heavier. So, it opens special valves at the bottom of these tanks, called floodgates. Seawater rushes in, and because air is lighter than water, it's forced out through vents at the top. As the water fills the tanks, the submarine becomes heavier, and its density increases. But here is the clever part. The crew doesn't just flood the tanks completely and plummet to the ocean floor. They let in just enough water to achieve neutral buoyancy. At this point, the submarine is essentially weightless in the water column. It's like an underwater blimp. Now, to actually drive it deeper, it uses its diving planes or hydroplanes. These are wing-like control surfaces located at the bow and stern. By angling these planes downward, like the elevators on an airplane's tail, the water flowing past them forces the nose of the submarine down. The submarine then uses its propeller to fly itself deeper into the ocean, all while maintaining that precise neutral buoyancy. So, how does this behemoth, sitting silently hundreds of meters deep, get back to the surface? By reversing the process. To become less dense, it needs to get rid of the heavy seawater in its ballast tanks. It does this by using its most powerful tool for surfacing: high-pressure air. The submarine has massive banks of air, compressed to incredibly high pressures. To surface, it opens valves that blast this compressed air directly into the bottom of the ballast tanks. The air, expanding rapidly, forces the seawater out through the same floodgates it entered. The tanks are now full of air again, making the submarine less dense than the water around it. With positive buoyancy, the submarine begins to rise naturally. The crew then angles the diving planes upward, helping to steer the sub towards the surface. You'll often see a huge plume of air and water erupt around a surfacing submarine. That's the compressed air, finishing the job of emptying the ballast tanks as it breaks the surface. Of course, it's not quite that simple. Submarines need to be perfectly balanced. They have smaller trim tanks to pump water fore and aft, adjusting their angle or trim. They even have a negative tank for a quick initial dive. And what if something goes wrong? What if the power fails and they can't blow the ballast tanks? Submarines are designed with multiple fail-safes. In a true emergency, They can release heavy emergency main ballast tank weights, or use powerful propulsion to literally shoot towards the surface. The safety of the crew is the absolute priority. So, there you have it. From the dream of deep-sea exploration to the reality of a machine that manipulates gravity itself through the principles of buoyancy and density. It's not magic. It's masterful engineering that turns a simple scientific principle into a capability for exploration, discovery, and defense. The next time you see a video of a submarine slipping beneath the waves, you'll see more than just a machine. You'll see a vessel full of air becoming a vessel full of water, deliberately making itself sink. You'll see controlled wings guiding it into the deep, and you'll know that to return, it harnesses the power of compressed air to reclaim its buoyancy and rise back into our world. It's a testament to human ingenuity, our relentless drive to explore every corner of our planet, from the highest mountain to the deepest trench. Thanks for joining us on this dive into the science of submarines.